Bad news for Monsanto and such other critters. Despite the Fukushima attack, Japanese researcher Lady Haruko finds a cheap way to stem cell production. Posted by Isa Kovic on Rumor Mill News. Stem cell researcher Dr. Haruko Obokata on breakthrough. The young researcher in Japan has been facing the world's media after her stem cell studies were heralded as a major scientific discovery. Dr. Haruko Obokata's work, published in the journal Nature, showed stem cells can now be made quickly just by dipping blood cells into acid. The breakthrough at the Riken Center for Developmental Biology was achieved in mouse blood cells, but could have the potential to start a new age of personalized medicine. Stem cell researchers are heralding a major scientific discovery with the potential to start a new age of personalized medicine. Scientists in Japan showed stem cells can now be made quickly just by dipping blood cells into acid. Stem cells can transform into any tissue and are already being trialed for healing the eye, heart, and brain. The latest development, published in the journal Nature, could make the technology cheaper, faster, and safer. The human body is built of cells with a specific role: nerve cells, liver cells, muscle cells, and that role is fixed. However, stem cells can become any other type of cell, and they have become a major field of research in medicine for their potential to regenerate the body. Embryos are one ethically charged source of stem cells. Nobel Prize-winning research also showed that skin cells could be genetically reprogrammed to become stem cells. Now, a study shows that shocking blood cells with acid could also trigger the transformation into stem cells, this time termed STAP, stimulus-triggered acquisition of pluripotency cells. Dr. Haruko Obokata from the Riken Center for Developmental Biology in Japan said she was really surprised that cells could respond to their environment in this way. She added, "It's exciting to think about the new possibilities these findings offer us, not only in regenerative medicine, but cancer as well. The breakthrough was achieved in mouse cells, but research is now taking place to achieve the same results with human blood." Chris Mason, professor of regenerative medicine at University College London, said if it also works in humans, then the age of personalized medicine would have finally arrived. He told the BBC, "I thought, my God, that's a game changer. It's a very exciting but surprise finding. It looks a bit too good to be true, but the number of experts who have reviewed and checked this, I'm sure that it is. If this if this works in people as well as it does in mice, it looks faster, cheaper, and possibly safer than other cell reprogramming technologies. Personalized, reprogrammed cell therapies may now be viable for age-related macular degeneration, which causes sight loss. It takes 10 months to go from a patient's skin sample to a therapy that could be injected into their eye, and at a huge cost. Professor Mason said weeks could be knocked off that time, which could save money, and as would cheaper components. So Dr. Haruko Obokata explains how she nearly gave up on the project when fellow researchers didn't believe what she had found. Revolutionary. The finding has been described as remarkable by the Medical Research Council's Professor Robin Lovell Badge, and as a major scientific discovery by Dr. DiScoVeRy, LLIC, in a reader in Stem Cell Science at King's College London. Dr. LLIC added, the approach is indeed revolutionary. It will make a fundamental change in how scientists perceive the interplay of the environment and the genome. He added, it does not bring stem cell-based therapy closer. Really? We will need to use the same precautions for the cells generated in this way as for the cells isolated from embryos or reprogrammed with a standard method. And Professor Lovell-Batch said, it is going to be a while before the nature of these cells are understood and whether they might prove to be useful for developing therapies. But the really intriguing thing to discover will be the mechanism underlying how a low pH shock triggers reprogramming and why it does not happen when we eat lemon or vinegar or drink cola. Isaac Kovic. Wow, this is very fascinating. Very, very fascinating. And as far as, what I'm thinking about is for people such as people that have epilepsy, this is really, really hopeful. And also for people like myself who have Morgellons, hopefully someday we'll find a cure for this terrible suffering, and which appears to be some form of genetic damage. Thank you so much for watching this video, and I will post a link below.